All right, let's get started on the problems for Chapter 4. Starting off with number 21. This chapter, again, is going to be on some solution chemistry stuff, which a lot of it has been not as much of a focus for College Board for the last couple of years. But it's still important to understand a couple things, which we did talk about in the lecture, on the online lectures. And you'll hear me say as we're kind of going through these. Some things that you should be able to remember. It'll make your life a little easier. All right, 21. Will the precipitation occur when the following solutions are mixed? If so, write a balanced chemical equation for the reaction. So the first reaction we're looking at here is sodium carbonate and silver nitrate, mixing these two things up. So I will just write these out so we can see it. Sodium carbonate and silver nitrate. And we're going to put together the two potential products. So looking at these, the way I would look at this is looking at the two cations and do a switch on those, and understanding that silver is a +1 and sodium is a +1, carbonate is a 2-, and nitrate is a 1-. So you do have to keep track of these pluses and minuses. And this is another one of those things I will point out right now, is I know it's one of the things that students traditionally struggle on, equation writing. So it's one of the things that you should really work on to have it be something that is a little more, it's not an obstacle for you. All right, I'm going to write this up as sodium and nitrate, -1 +1, so I'm not going to have to worry about those. And then silver carbonate, -2, so I put the 2 down here, and a 1 doesn't affect anything. Okay, some things that you should commit to memory. Anything that has sodium in it is going to be soluble, never a precipitate, ever. Anything with nitrate, always soluble, never precipitate. So this is absolutely out. And if you look at some rules, which I would have handed you in class, I think I also have it on the webpage for you as far as a reference sheet. Carbonates generally are going to be insoluble. Carbonates are generally insoluble unless it's with something like group 1, like sodium, or ammonium. Other than that, with maybe it's an exception or two, it's going to be insoluble. So that is how problem A is going to go. All right, let's look at B. B, we're going to deal with sodium nitrate. I can already tell you how this one's going to go. And nickel sulfate. And nickel is a 2+, and sulfate's 2-, so we don't see those numbers. Okay, so just like I said in the previous problem, we're going to switch nickel and sodium. So nickel will be over here and sodium will be over there. But look at who these two guys are. Always soluble, no matter what. Always soluble, no matter what. So when you stick either one of these onto this, and this one matches up with the other, no matter what, it doesn't matter. This is definitely going to have no precipitates, no reaction. So it's going to be soluble for both of these, because sodium will always be soluble and nitrate will always be soluble. So no matter who gets paired up with who, it's soluble. All right, last one, C. I'm going to put it down here so I got a little bit more room. We have iron sulfate, iron 2 sulfate, plus lead 2 sulfate. I'm sorry, lead 2 nitrate. All right, so let's pair these up. I'm going to switch the iron and the lead. So I'm going to have, I'll do iron first and nitrate. Iron is 2+, so there it is. And then I have lead with the sulfate, +2 and -2, those guys cancel out. I have to make sure this is all balanced out, so I take a look. Nitrates I have 2, nitrates I have 2. Lead is 1, lead is 1, sulfate is 1, sulfate is 1, iron is 1, and iron is 1. So I know I'm going through this kind of quickly. You can slow it down and take a look at it yourself if you like. As far as who potentially is not, definitely not a precipitate, nitrate, never. So I can cross that one out, think about it. Definitely not going to be one. But sulfates generally are going to be insoluble, and lead is one of them guys that's going to work for that. So this is one of our precipitates. Lead sulfate is a solid. So there you go. That is our precipitate for that one. And again, you should have a table available, and you can kind of go through here. It's like I'm not just making this up. You can go and reference these, and it'll tell you what sulfates generally are or aren't soluble. You can look that up yourself. Okay, oxidation numbers. We talked about this in the lecture, and it's something that we'll get a feel for it now, but we'll hit it a lot harder in chapter 19 or 20. I think it's 20 that we'll talk about that more. When we look at these, actually I got the first one hanging out over here for A. We're looking, there's some things you can count on as general rules, and the other ones have to adjust to that. For example, oxygen is generally 2- for each one. So if this is 2- and I have two of them, it's -4. Sulfate is for its oxidation number. It does vary. I'm sorry, sulfur. So in this particular case, sulfur is going to be 4+. Sulfur is 4+, oxygen is 2- each. Let's take a look at this one. We're trying to figure out what carbon is in this compound. For that one, if we take a look at it, we're going to say that chlorine is generally 1- each. Oxygen, just like it was in the previous problem, is generally 2- each. So if I add those up, 2- and 2- is 4-. Carbon has to make up the difference, and that is going to be 4+ for carbon. Okay? C, we want to know manganese. Oxygen, 2- each, and I have 4 of them, so I'll hold that in your head, 8-. Let's write over here, 8-. Group 1s in a compound are always going to be 1+. So for this whole compound to be 0, manganese has to make up the difference. So 8- plus 1, 7-. Manganese has to be 7+ to make up the difference. All right, in this compound, oxygen, 2- each, only have 1. Bromine, generally, -1. And if we look over at the, well, I take that back, excuse me. For this particular example, bromine is actually going to be the one we're looking at. So, oops. Bromine can vary. So oxygen is -2. Hydrogen generally is going to be 1+. Generally going to be 1+. There's only 1 or 2 examples, which we'll talk about some other time. Bromine has to make up the difference. So this is kind of an unusual, interesting example. Oxygen is very electronegative, which is a bigger conversation we'll get into. It happens to be here, so we're doing it. Bromine in this particular example is going to be 1+ because of the oxygen and the hydrogen. Okay. Arsenic. It's simply arsenic is elemental. In this example, if something that's in its elemental state and there's no charge upon it, which there wouldn't be, it's going to be 0. Last one here, this is a nice, interesting exception. It is potassium peroxide. And in peroxides, oxygen is going to be 1-, not 2-, 1-. And group 1s, the reason for this in this example, group 1s are always 1+. So that is what influences the oxygen for that particular example. Okay. All right. Let's look at number 51. Actually, this might be a good spot to just kind of break on this one, and we'll come back and do a second lecture.